In this video, we're going to look at example 1 from topic 2, where we solve linear equations. So the question is, what is the value of x in the equation 2 times the quantity x plus 4 divided by 3 minus 8 equals 32? So to solve this, I'm going to need to isolate x. And to do that, I will need to get rid of the 2, the 4, the 3, and this 8. So we want to bring all of those over to the other side. Now, how do we decide what order we do this in? That's kind of the key to this, right? That's how you would solve a linear equation. So we're isolating x. Now we want to ask ourselves, what do we normally do? Let's just pretend this didn't exist, and let's pretend that x was a number. You'd have to ask yourself, all right, what's the first process that I would do? Well, looking here, the first thing I would do if I followed kind of, your PEMDAS, your parentheses, exponents, multiplication, division, addition, subtraction, the first thing I would do would be to add 4. After I added 4, I would then multiply by 2. Then I would divide by 3. And then I would subtract 8. Right, so if I was solving this again, let's pretend that this was the number, let's use 5. You would add 4, then you would multiply by 2, then you would divide by 3, and then you would subtract 8. So when we're solving this, we're trying to isolate that x value. We want to do these in the opposite order. So we're trying to undo operations to get the x by itself. So I'm going to rewrite my equation as 2 over x plus 4 divided by 3 minus 8 equals 32. And the first thing I want to undo is what I would do last. So normally I would subtract 8. So if I'm undoing that, I'm going to undo the subtraction of 8. And to do that, I would add 8 to each side. So these two would effectively cancel each other out, right? We're trying to undo those operations. So we're left with 2 times x plus 4 divided by 3 on the left, and then 32 plus 8 would be 40 on that right side. Now we've got rid of the subtraction of 8, so now we want to get rid of the division by 3. And to undo division, we would multiply. So I would take this side, the left side, and I'm going to multiply by 3. And whatever you do to one side, you have to do the other. So we're going to multiply both sides by 3. Again, these effectively cancel each other out. So those 3's are going to drop out. You're not actually going to multiply the 3 by the 2 because the whole purpose is to get rid of this denominator. So we're left with 2 times x plus 4 equals 40 times 3 would be 120. So we got rid of the division by 3. Again, we're working backwards, so now let's get rid of the multiplication by 2. To undo multiplication, we would use division. So I'm going to divide each side by that 2. Once again, these will effectively cancel each other out. So I'm left with x plus 4 on the left, and then 120 divided by 2 would be 60. And then finally, I'm going to get rid of the addition of 4. So to undo addition, we're going to use subtraction, subtract each side by 4, and I'm left with x is equal to 56. And this would be my solution. If I wanted to check this and make sure that I've done this correctly, what I could do is I could take that 56 and plug it back into the original problem. So 2 times 56 plus 4 divided by 3 minus 8. And we want to know, does that equal 32? So we would get 2 times 60. We get 2 times 60 if we were simplifying this. So this is our check. 2 times 60 would be 120 over 3 minus 8. And notice while I'm doing this now, I'm following these steps up top. I'm adding 4, then I'm multiplying by 2. Now I would divide by 3. So I would have 40 minus 8 equals 32, and we're still trying to figure out, does that equal? And then that would be 32 equals 32. So this all checks out. So the 56 would be our correct answer. So once again, when you're solving equations, especially when there's multiple steps, here we had 4 different steps we had to undo. It's helpful to write them out as, all right, what would I normally do first, second, third, fourth, and so on, and then just undo that, all right, work in the opposite order. And that's it for topic 2, example 1. Take a look at the try it problem. That'll help you with that, and decide what you would have to undo first, and then go from there.